Hi, everybody. We're ready to start a new chapter, which is chapter 5, tissues. So as we always do, let me begin by sharing my screen and going to the PowerPoint presentation. So we've got 4 major types of tissues that are discussed in chapter 5, and you see those listed here on this table 5.2. I am not going to really go into any detail of these 4 at this particular moment in time. I think it would be helpful to peruse the function and location, and as it mentions, their distinguishing characteristics of the 4 major types of tissues. So if you ever want to come back and get the overall big picture of chapter 5, this is an excellent table that does a good job kind of giving you an overall summary of epithelial, connective, muscle, and nervous tissues. I'm going to divide this chapter into 3 modules, beginning with epithelial tissues. Then I'll do a second module strictly over connective tissues, and then we will combine muscle and nervous tissue at the end for the 3rd module of chapter 5. So you're going to see this slide, this box, I guess, appearing several times throughout the next few modules. And I think it does a good job, again, reiterating sort of what the takeaway message is of this chapter as you begin to learn the different kinds of tissues. We're going to learn about the 4 types. We're going to talk about different kinds of epithelial, different kinds of connective tissue, different kinds of muscle. So in addition to the 4 major types, we're going to learn different subgroupings. And we want to begin to connect not only the types of tissues, but where do we find them in the body, and where, or what I should say, are their major functions. And I think your textbook does a really nice job as it shows not only histologic photographs of stained tissues, but it also has an artist's sketch of the tissue photo. And then it does these little insert areas that highlight different parts of the body where you can find the specific tissue that's being just talked about or addressed. So again, I think the book's done a pretty good job in organizing that. So what are they? Where do you find them in the body, and what is their function? These would make excellent flashcards, you know, if you're trying to learn the tissues. And remember, not only do we need to know this for lecture, but we're also learning about these in lab as well. So you got to learn it for both. Might as well just do a good job, and you're killing 2 birds with 1 stone that way. So regardless of the type of epithelial tissue you look at, or epithelia, the plural term, all of these epithelial tissues must have what we call a free surface or apical surface that faces some space. That could be an external space, which is the case for our skin, right? The skin of our cells faces the room. That's a space. So we could talk about the apical surface of what we call stratified squamous, that's your skin. And the very apical surface is that which is on the very outside of your skin. Or we could talk about the internal spaces that some of these cells will face. For example, if you look at the digestive tract, all the way from really the mouth down through the anus, we have cells that line that tube, that interior yet somewhat exterior tube open to the outside. So it really depends upon where we are as to what defines the free surface, the apical surface, and which defines what is referred to as the basement lamina or basement membrane. So that's going to be opposite the free surface of the epithelia. It's the basement membrane or basement lamina. And as it indicates here, this structure, this basement lamina or membrane, acts to glue the epithelial tissue to the underlying connective tissue. So connective tissue lies underneath epithelial tissues. So one way to begin to differentiate the various types of epithelia is to think about these two very important criteria. The shape of the cells that make up this epithelial type of tissue, and how are those cells arranged. So you see the three basic cell shapes there. Squamous, that should read flattened, I'll change that, flattened cells. And the metaphor that I give is when you fry eggs in a skillet or in a pan, okay? The egg that you're frying is the epithelial cell, the squamous cell. And the yolk of the fried egg is like the nucleus of the cell. And that's sort of what they look like, as you'll see in a few moments. They're very flattened and with a very obvious nucleus inside each cell. Or we could talk about cube-shaped, cuboidal epithelial cells. Or we could talk about columnar, cells that are taller than they are wide, as the name again implies. These are the three primary shapes that you're going to see with respect to the cells that make up epithelial tissues. And then, of course, the second criterion is how are those cells layered? Are they in a single layer, in which case we call them simple, or are they multiple layered or stratified? And so by knowing the three shapes of the cells and thinking about the layering arrangement, we could talk about a variety of different types. In fact, we could define 6 different kinds of epithelia here. Simple squamous, simple cuboidal, simple columnar, stratified squamous, stratified cuboidal, stratified columnar. Okay? Now, those are not the only possible types, but that's the vast majority. So again, learn the shapes and the names, and then think about the layering arrangement of those cells. In fact, here's a table which does a nice job summarizing the major types of epithelial tissue that we will be talking about. And I want to draw your attention to several of these that I've crossed out. So those you can omit. We're not going to talk about stratified cuboidal or stratified columnar. We will talk about these other, 2, 4, 6, 7 types of epithelia. So again, focus on the names, the arrangement, and the shape of the cells. We will begin to also learn their function and just as important, where in the body do I go to find these different kinds of epithelial tissues. So let's start off with simple squamous, which is really the simplest of the 7 or so that we're going to be learning. This is a single layer of flattened cells, as we've described a moment ago with respect to our 2 criteria. So as you might expect, these flattened cells are thin. They're easily damaged, as we note in the box here. Here is a photograph in the upper right-hand corner of the slide of some stained simple squamous cells. We don't so much notice their flattened morphology because we're looking down from above, but we can see their relative size. We can see the cell membranes, of course, very nicely, and we can see the prominent nucleus inside each of those squamous cells. Here's an artist's sketch, of course, of simple squamous, and here's a histologic section of simple squamous. A few things we need to point out. We said that all epithelia have a free surface. All of them will also have a basement membrane. Well, where's the free surface? Well, you see it labeled, obviously, here, but it's on the surface. So this is facing a space up here where I'm moving my little arrow around. That's the open space, which I'll talk more about in just a moment as to where we find this. And then we can go to the other end of the cells here, shown in dark purple. This is the basement membrane, that adhesive margin that attaches the simple squamous to the underlying connective tissue, shown here in light purple. In this histologic section, we can see 4 simple squamous cells, as evidenced by the 4 nuclei. Here's that free surface here at the top. In light blue is the open space that must be there. And then, of course, if we look very closely, we can see at the bottom of these cells, at their base is the basement membrane. So it's this structure that runs right about here. Everything below it is, by definition, connective tissue down here. Now it's telling us to go to the lungs to look for simple squamous. It's not the only place you can find it, but it's a good place to go. In your lungs are microscopic air sacs called alveoli. And it's in the alveoli, when you inhale, that air is brought in, those alveoli inflate sort of like a little balloon. And on the surface of the alveolus, which is one air sac, are blood capillaries. So when you inhale air, that oxygen that you're inhaling eventually will move into the alveoli. It will diffuse across the membrane of the alveolus, which would be basically the simple squamous that I'm showing you here. Only it's going to be sort of in a circular balloon-shaped morphology rather than a flat surface. And that oxygen will then diffuse, as I said, across the cells and then into the bloodstream, where you will distribute that oxygenated blood to your tissues, all different kinds of tissues. And when that blood comes back to the heart and the heart pumps it back to the lungs, then the CO2 that's built up in the blood will diffuse from the blood through the simple squamous cells of the alveoli and into that space, which will lead to the outside of the body, and you exhale that CO2. So one important function of simple squamous is diffusion, and it can be quite easy to see that function if you think about the fact that these cells are extremely flat. There's only one layer thick, and so as we move from higher to lower concentration, that's much easier performed if we have to cross a very thin single membrane, like we have here in simple squamous. Simple cuboidal. Again, let's look at the sketch. Here are our cube-shaped cells. Here's the free surface at the top facing some space. Here is the basement lamina in purple, and below that the connective tissue. Here is a stained histologic section taken from the kidneys. We look at this slide in lab. And what we see here are two kidney tubules that have been cross-sectioned. Okay, so this tubule is running out of the monitor toward you and also through the monitor away from you, a cross-section. So the lumen here in white would actually contain liquid, might be what will be the future urine, maybe that you'll avoid, but it's going to be some liquid here in the tubules of the kidney. And therefore, this is the space that this epithelia faces. So here's the free surface. I'm going to just trace that with my mouse, with the arrow. This is the free surface side of the simple cuboidal cells. And then here would be the basement membrane. Right here, it goes around. Now that's of this tubule. If we look at the other tubule, here would be the apical surface or free surface, and I'm outlining. This would be the basement membrane. Come up around like here, and they would actually kind of curve around and then come back like that, and then around. The major function of simple cuboidal would be in secretion, absorption possibly, and protection. Because we have secretion of certain metabolic waste products that go into the formation of urine, but the kidneys also reabsorb water and other important electrolytes and glucose and other organic compounds that you don't want to void. You don't want to lose that. You want to maintain that. So through a process called reabsorption, we conserve those particular important organic compounds. But we also secrete and get rid of metabolic waste products as well. So that's why we have that dual functionality, secretion and absorption. And not only do we find them here in the kidneys, but as your book mentions, the surface of the ovaries and various ducts that line certain glands can be good places to look for simple cuboidal epithelium. Here's simple columnar, one layer of column-shaped cells. You see that very nicely in the sketch. Here's our basement membrane in purple. Here's our apical surface here on the top, our free surface. Here's connective tissue down below. Now, this particular sketch is showing simple columnar as it is found in the small intestine, where we have primarily absorption of organic material that we've digested, but there's also secretion of enzymes here as well. So again, with regard to function, you could list, like you did with simple cuboidal, secretion and absorption and protection. But when we talk about simple columnar in the digestive system, specifically here in the small intestine, we have on the surface of these cells structures called microvilli. Now again, the space the apical surface here is facing is where the food would be that you digested or are digesting. So you can see again absorption of those organic compounds, those monomers, building blocks. But there could also be secretion of enzymes to continue the digestive process, all taking place thanks to these simple columnar cells. But back to the microvilli. These are microscopic structures on the very tips, on the apical surfaces or free surfaces of all these simple columnar cells that increase the surface area for maximum absorption of organic compounds, amino acids, monosaccharides, glycerol, fatty acids, those sorts of things. And on this stained histologic section, again, to orient you, here are the simple columnar cells. You can see the nuclei very nicely. Here is the basement membrane. It would come up like this and then curl around and come back down. This would be connective tissue in the very center of what's called a villus. And on the very, very apical or free surface of these cells is that structure that I was referring to, or those structures called microvilli that increase the surface area for maximum absorption. Let me see if this next slide shows the microvilli. Yeah, so here we see magnified 33,000 times with an electron microscope on the tip of one simple columnar cell, the presence of hundreds and hundreds, if not thousands, of microvilli. Pretty amazing structures. Okay, I'm going to go back to this slide we were at a moment ago and mention that embedded in the simple columnar cells here in the small intestine, we also see special types of cells called goblet cells. And these goblet cells secrete mucus externally toward the free surface side of the cells. And that mucus helps keep the inner lining of the small intestine sort of slippery and lubricated so food can pass through more easily during what's called peristalsis. We'll be seeing goblet cells again in a few moments, but just remember they are instrumental in producing mucus. Now, I also note here it says may be ciliated or non-ciliated. These are non-ciliated simple columnar cells. Okay, these are microvilli at the tips, at the apical surfaces. There are some simple columnar cells, as you find in the fallopian tubes or oviducts, that are ciliated. And the function of the cilia there in the fallopian tubes, you may know, is to help propel the egg from the ovary toward the uterus. Yeah, so that's the only other place you find ciliated simple columnar in the fallopian tubes. And then you run into some simple columnar epithelia that may not have any cilia at all. In fact, most don't. They might have microvilli, like the small intestinal cells do, but not all simple columnar necessarily will have microvilli either. They might have really nothing on the surface. They still absorb and secrete, but if it's not in the small intestine where you have absorption, there's no need for microvilli. necessarily. Okay. Now here's a special category that I did not talk about in the earlier slide where I was talking about the two criteria, cell shape and layering. It's called, obviously here, pseudostratified ciliated columnar. Now, the magic word here is pseudostratified. We just talked about simple columnar that is ciliated, i.e. lining of the oviducts or fallopian tubes. This is falsely stratified ciliated columnar, as we might find it, according to the insert here, in the upper respiratory tract. And I always think of trachea when I think of this particular type of epithelium. Think of trachea, but upper parts of the respiratory passageways also are ciliated. So let's again orient ourselves. Here's the cilia, obviously. This is the open free surface. Up here, this is where the air would be passing as it goes in and out of the lungs. Again, think trachea. Here's the basement membrane in purple, dark purple, and then here in lighter purple would be the connective tissue. Note the presence of goblet cells, which secrete mucus. And here's where the term pseudostratified comes in. Pseudo means false, falsely stratified. When you look at this histologic section on the right, you might get the impression, based upon the position of the nuclei, that this has got more than one layer of cells. And I can certainly see where most people would think that, because you have some nuclei that are down here near the basement membrane, as we see here, and then you have some that are, mid to high in the cell, closer to the free surface. So it gives the impression, doesn't it, of at least two layers. In reality, all of these cells touch the basement membrane, but not all will necessarily reach the free surface like we see with these four cells. They don't quite make it to the top. Most of the cells do have an apical surface, but not all of them do. And notice again the stratified nuclei to give the false impression that you have multiple layers, when in essence you only have one layer. So here's the goblet cells, obviously here in lighter blue, white almost. And you can see some of the mucus kind of coming out of the cells. It's kind of interesting. And they're going to basically, the mucus is going to coat the cilia. The purpose of the mucus is to trap airborne particulates. So when you inhale air, you're inhaling lots of dust, particulates, bacteria, viruses. You'd be amazed at what's floating around in the air. And so most of that material falls on the mucus in our upper respiratory tract. And then the cilia will move that mucus upward, and then you swallow that and take it into the stomach, where the pH of the stomach, being so acidic, will knock out any possible pathogens or disease-causing microbes. Yeah. Now, people who smoke for many, many years, the smoking aggravates the goblet cells, and in response, they produce copious amounts of mucus over time. And what can happen is these cilia get kind of tired and worn out, and they basically die as a result of the continuous production of excessive mucus due to the irritants in the cigarette smoke. So the cilia can die. They can no longer move the mucus upward. And so what ends up happening is the mucus begins to settle due to gravity into lower parts of the respiratory tract and the lungs. And somebody who is a chronic lifelong smoker may develop what's called smoker's cough, right, where they have to literally hack up the mucus because the cilia are shot, they're gone, they're not going to come back. And there's only the physical mechanism of coughing it up to get rid of the mucus, because obviously it impacts or impairs the ability of oxygen and air to get in and out of the lungs. Okay, moving from simple to pseudostratified now to stratified epithelia, layered cells, right? We come across stratified squamous. And again, I think it's pretty self-explanatory as to the stratification. You can see that there are at least, 2, 4, 6, 8, or 10 different layers of flattened squamous-shaped cells here. I will note that as you get closer to the free surface, which is up here, the cells take on a more characteristic fried egg in a pan sort of appearance. while those that are closer to the basement membrane may look less flattened. I would not call these cuboidal, however. These are all squamous, but they're less flattened here toward the basement membrane. And what ends up happening actually with regard to where we find this tissue in the skin, also in the esophagus, and in the oral cavity, these cells are constantly being sloughed off and shed, and they have to be replaced. And so there's active cell division going on down here. We'll talk more about that in chapter 6. But there's active mitosis going on here, very near the basement membrane. So there's a constant supply of cells to replace those that are sloughed off. Again, these are all squamous, taking on their flattened characteristic shape as they get closer to the free surface. This is a really interesting stained section. Again, very easy to see the apical surface here at the top, the free surface. This would be the outside of your body, for example, if this was the skin. If this was the esophagus, this would be where the food is that you're swallowing on its way to the stomach. Okay, the space contains the food. And as you proceed deeper into the tissue, you see where you go from this kind of light purple pink down to a dark purple, then off into a very, very different looking kind of tissue. It's really almost like white, right? This is the connective tissue. But what I tell students is as you proceed deeper into the tissue, when you run across an area where the color and the overall look of the tissue just really changes substantially, that often demarks or indicates where the basement membrane is. So the basement membrane is going to come up here, come around, up, down, and over. So this is all simple squamous. This is all connective tissue. So in terms of function, what do you think? If I say skin, you know what the skin does, right? It's an effective barrier, right, against microorganisms. It also prevents you from dehydrating as well. Because somebody, let's say, who has a bad burn has to worry about two major things: infection and dehydration. If you lose your skin because of chemical damage or a flame, for example, a really bad flame injury, people succumb often to infection, unfortunately, but also you got to worry about water loss, which can lead to all sorts of issues. Here is another special category referred to as transitional epithelium. Two things to make note of here. One is the fact that we have a layered type of tissue, as shown here in both of these sketches. So I think we're looking at least 3 layers right here, maybe 4. We don't have the characteristics flattened cells, although you might say these look kind of cube-shaped. Well, yeah, they kind of do. We would not call them cuboidal, however. This is all transitional. And the reason that this gets the name transitional epithelium is because this epithelium will change its shape depending upon how much pressure is being placed here on the free surface side of the tissue. It tells us to look in the ureters, which remember are the tubes coming from the kidneys to the bladder. We can look in the bladder wall, and we can look here in parts of the urethra for transitional epithelium. Okay, so ureters, bladder wall, parts of the urethra is where you find this type of epithelium. The free surface side, let's pretend this is the bladder we're talking about here. The free surface side is where the urine is going to be held up here. So these cells will face the urine, the liquid, as will these cells in this histologic section. Or these cells down below. The white space is going to be that space that contains the urine. If the urine is released from the bladder, there's no longer any pressure placed on this tissue. And so we have very distinct multiple layers visible, both in the sketch and in the histologic stain section here, right? We can see those cells quite nicely. But as soon as we begin to add urine from the ureters, from the kidneys, and the bladder begins to fill and there's more pressure being placed on the inner wall of the bladder, look what happens. We start to compress or push down on the free surface. The effect is to flatten the overall transitional epithelium, like we see in the sketch, as well as in the histologic stain section. So you have to ask yourself, is there stretching going on or not? If there's not, the cells look somewhat cube-shaped. If you want to think of the top layer as cube-shaped, that which is closer to the free surface. But these down below kind of take on a very kind of bizarre, arrangement of shapes. But when you start to put pressure on these cells, they become much more stretched, much more flattened, although we would not use the term squamous here. Okay, this is still transitional epithelium. The only place you find it, again, ureters, bladder wall, and parts of the urethra. And then we have our last category of epithelium called glandular. So we're going to be talking about glands here a little bit. Glands are clusters of cells that produce substances that are either secreted into ducts that lead to some location, or some glandular epithelium can produce secretions that get dumped directly into body fluids, like the bloodstream. So let's talk first about those which secrete their products into little passageways called ducts. Ducts. So there's a couple examples we could give. We could talk about, as it does here, salivary glands. When you put a lemon drop in your mouth and you begin to salivate due to the very lemony flavor of that candy, you begin to salivate. Or the classic experiment done by Pavlov, where he sprayed the meat powder into the dog's mouth, and the dog begins to salivate, right? Then he associates a bell with the spraying of the powdered meat, and the dog salivates. And rather than spraying the meat, he just rings the bell and the dog salivates. It's a classic psychology experiment, right? You've all heard of it. So these ducts lead from the glands to the inside of your mouth, your oral cavity. Sweat glands have ducts that lead to the surface. You know that when you get too hot, your body attempts to thermoregulate by evaporative cooling. You begin to perspire, sweat, and that sweat gets to the surface by passing through little passageways. These are called exocrine glands. Sweat glands are exocrine, salivary glands are exocrine. The pancreas can produce certain secretions, alkaline secretions that help to buffer the acidity coming from the stomach as it enters the small intestine. So there are ducts in the pancreas, so we would define the pancreas as an exocrine gland. There's lots of different examples that you'll be hearing about in A&P 1 and 2. Now compare and contrast that type of glandular epithelium to the type that produces its secretions and dumps them not into ducts that lead to some surface, like the inside of your small intestine or the surface of your skin, but rather these are dumped obviously here into blood. That's the primary body fluid or tissue fluid that I think about. And these are commonly kind of collectively referred to as endocrine glands. Now, you know the endocrine system, it's one of the 11 organ systems, and we associate endocrine system with hormones, don't we? So these are glandular epithelia, your endocrine glands, that produce hormones that get dumped right into the bloodstream and are carried throughout the entire body. And there are typically some target tissues that respond to those hormones. And we list, of course, the pituitary gland, pineal gland, thyroid gland, the testes and the ovaries, dump their hormones directly into the bloodstream. What's also quite interesting, the pancreas can produce hormones as well and would thus be defined as an endocrine gland. But we just said a moment ago that the pancreas can also secrete alkaline solutions and enzymes via ducts into the small intestine, right? So the pancreas is both an exocrine gland and an endocrine gland. So that's kind of interesting. Okay, so that wraps up epithelial tissues. In the next module, as it indicates here, we'll talk about the various kinds of connective tissues. So we'll see you a little later.